Hi, everyone. We'll get going very, very shortly. We're just going to give it a couple more minutes to see if we've got more people arriving. Thank you. Okay, one more minute and I think we'll be underway. Right, I think we'll get underway. Thanks, everyone, for coming along, attending our webinar today. We really appreciate it on behalf of Race for 2030 for coming along and finding out some of the interesting things that are happening in our transition to our energy future. Before we get started, just remind everyone to keep your microphones on mute as we get started, and to let everyone know that this meeting is being recorded, and if to make sure that you're happy with that, and we will make the recording available for those who haven't been able to attend today. So we might get underway. Right. So as we get started, I'd just like to acknowledge the traditional owners of the ancestral lands in the various locations on which we meet today and recognise their continuing connection to land, water and culture. Pay respect to elders past and present, acknowledging them as the traditional custodians of knowledge and of these lands. Today, the plan is that I'll provide a short summary of RACE before we launch into the demonstration. I'm looking forward to that. We've got the team from GridGuru and Mark Swagner from Monash with us to talk that through. Following the demonstration, we'll have an opportunity for question and answer time, and I'd encourage all of you to access the Slido page. I'm not sure if that Slido is appearing on the screen well enough. Yep, I'm told we can pick that up, so that's good. So I'd encourage you to access that and put your questions on that platform as we move forward. So Race for 2030, I know a lot of you are already aware of it, but I'm very pleased to have an opportunity that we can showcase some of the projects in the coming months that we are co-funding as we seek to drive impact in the energy transition. For me, impact relates as much to investments as it does to the technology and the modelling that comes with driving the transition. More effective and more efficient networks and better regulation occur when we bring everyone along for a whole of systems change. We run 5 different programs within RACE in the areas of homes, Race for Homes, Race for Business, Race for Networks, Race for EVs, and Race for Change. And you can see some of the themes that we focus on in each of those, and we have a whole raft of projects operating under each of those. You're welcome to go to our website and have a look at any time at some of those projects that are underway, or talk to Annie or myself about those projects moving forward. We'll have our contact details available in a moment. So some of the interesting projects that are launching right now that I'm really excited about include a project that we're doing with QUT and Powerlink and Ausgrid, which is operating networks in the presence of increasing numbers of grid-forming inverters. And I know there's some interest from some of the transmission companies across the country in that project, and we will start providing more information moving forward. We were discussing that this morning. The modelling's just getting underway to develop some of the analysis that's going to go for that project. We also have Energy Masters, which South Australian Power Networks is leading, which will see 500 home energy management systems installed in households and explore how networks will operate when there's large numbers of customers who are empowered with HEMS. And finally, another project, this one with Essential Energy, called Smart Energy Communities, which is about optimising the operation and participation of microgrids in regional and remote areas, and some really good behavioural and regulatory stuff coming out of that as well. So they're just some of the projects that we are doing, but that's not why we're here today. Today we're here to talk about GridGuru. Sorry, just make sure I've got everything in place. So this project started from prototype digital twin that we funded earlier in the year. The prototype, which you'll see today, was very, I feel, really quite well executed. It showed some things I'd never seen in digital twin technology before. And it was delivered by a team that included Marcus Wagner and his group from Monash University, and the group from RedGrid in Melbourne. They developed this, they're going to show it today, and the plan is, if there's interest, that we will take that forward and develop into a much bigger project. We had a webinar last week where we talked about our recent report we released called CER Unleashed, and Alison Reeve was at that webinar. She's from the Grattan Institute. She made a really interesting comment, I thought. She said, our electricity networks were built by people, for people, and nowadays they consist predominantly of people and, importantly, of their behaviours. And we need to include people in the transition if we're to take an authentic and truly systems approach to the transition. And so we need tools to be able to do that. We need better engagement, better communications, and this product is perhaps one of the ways that we can drive that forward. The product offers an opportunity for really fast modelling by technical operators such as network planners and control room staff, but more widely to network engagement people, those that are working in a whole range of environments, and it creates better opportunities to build simple, easily understood and interrogated visualizations of so many use cases. And some of the ones that I think of when I look at this project and what it can do is, seeking approval for network projects from the executive or the board of your organisation, presenting capital programs to regulators, perhaps engaging with shareholders or engaging with community forums or community energy cooperatives or even the media on crisis situations. It's also a way where operators could provide network self-service interrogation almost as a way of reducing the amount of resources that are focused on developing those network studies every year for projects that never go ahead. This digital twin is different from others for a range of reasons. It integrates a whole range of the most current technologies in machine learning and AI, which you'll learn about today. But more than this, it models not only the power constraints, but the physical constraints that exist around the network. And there's an opportunity for a range of environmental overlays that provide even richer insights into what's going on. More importantly, this digital twin can scale up from distribution transformer level up to zone substation level to bulk substation to the transmission level to whole of network, which makes it a really powerful way of explaining flow on impacts when you're looking at whole of system modelling. The ability to quickly develop and interrogate scenarios makes it a really useful tool for the future of our transition. And today you're going to meet and hear from the team at RedGrid and Monash. We're going to demonstrate the prototype and talk about this in more detail. Before I pass you over to Simon Wilson, who's the CEO of RedGrid, who will introduce the team further, I just want to again call out the code that's sitting there, the Slido code that's sitting there, and ask you to jump on that platform if you can. But I think without further ado, Simon, I will pass over to you to introduce the team.
Thank you, Neil. Thanks for the opportunity to speak to everyone. So I'm Simon. I'm CEO and co-founder of RedGrid. We've got some of our team on today. You'll hear from Jason and Phil, who are in the room together in Brighton at the moment. But Phil's our lead developer and chief engineer, and really a true artist when it comes to software development and this energy platform that you're about to see. And also we've got Jason, who is helping a lot with quite a seasoned executive from the energy space, and we're really privileged to have him helping with our discovery process and evolving this product. And we've got Emily Loving as well, who's our head of product, and really focused on a human-centered design approach, which is sort of, you'll see, has made its way into this product as well. But RedGrid, we're a software company for the energy transition. Our mission, might skip to the next slide if that's okay, Neil.
Sure. Oh, sorry. Apologies. Fast on the draw.
So our mission is to bring our expertise in emerging tech to this industry. So and our objective is to democratize the energy planning and design activity. So our working relationship with Monash, and actually the journey that you see in this platform coming up, really started in 2019, actually, where we did some work with Monash and started our relationship with them as part of their UN award-winning net zero initiative, which was effectively leveraged the Clayton campus as a microgrid. We helped them with some software capability, and that spawned this platform that you're about to see. Might skip to the next slide if that's okay, Neil. So spawning from that work was really a vision that we came up with, and that vision is to create a collaborative open energy modeling tool based on a secure and private architecture, and really using some leading edge software techniques and capabilities within its heart and within the fabric of the solution. So our hypothesis was really that such an approach and a platform would help bring our industry together and its data together in a way that would enable a faster and more efficient energy transition for us all, which is our objective, our broad objective. The platform that you're about to see, that Jason and Phil will go through, is really the foundation of that vision, I guess. And it has some pretty broad potential that hopefully we'll be able to showcase here today. But really, our project with Race and Monash has focused on these 4 areas within the platform. The ability to quickly and on demand identify low voltage network constraints, to leverage the platform for insights and evaluation capability in order to increase network hosting capacity. The ability to really easily and intuitively test, plan, and evaluate grid configuration optimizations for investment and planning purposes, and also to use data insights and some of this, the pretty spectacular AI capability that's emerging, to enhance customer engagement and improve network management. So we'll probably hand over to Jace, who's going to tell you a little bit about the architecture, and then we'll get into the fun stuff, which is the demo.
Okay, great. Good afternoon, everyone. Can we move to the next slide, please? Okay, great. So GridGuru is built on an open, extensible, intelligent, and interactive energy system. It's really built on a platform that's called Unity. So let's talk about why we chose Unity as a foundation for GridGuru. We knew from the beginning that we needed a platform that was not only powerful and flexible, but also capable of supporting the sophisticated demands of modern energy networks. Unity met all of these requirements and more, and here's why. Unity is a mature platform. Every entity in the model is treated as an economic actor. That means we can apply different profiles to each entity, down to the household or meter level. So for example, we can model how different homes respond to price signals, how they consume energy, or how they interact with the grid based on their own behaviors. Unity is open and extensible. One of its greatest strengths is the ability to create a system architecture that supports or allows for the running of separate sophisticated models, such as weather models, behavioral models, and energy usage models. Each of these can operate independently, but with Unity's API capabilities, their outputs are seamlessly integrated into GridGuru. This means that we can incorporate data from multiple systems and models in a dynamic way. Unity is also a leader in generative AI. The platform allows us to integrate powerful AI and machine learning technologies. And lastly, Unity is supported by a global platform of over 150,000 developers. It gives us a wealth of experience and innovation, ensuring that GridGuru remains at the forefront of technical advancements. If anyone here is a gamer, then they understand how complex and data-driven environments those games are. Halo is built on Unity, so this is the world's leading gaming platform. We're going to move slide now. Managing an electricity network is, so if we just go back, is really complex. Every day, you're tasked with a delicate balancing act, delivering low-cost, secure, and reliable power while keeping up with the demands of a once-in-a-generation energy transition. Today, regulators are requiring networks to be more open, transparent, and collaborative with all of your stakeholders. The question is, how do we do that? GridGuru provides the opportunity to use real data in a platform that produces results that are reliable and repeatable. Built on the world's leading gaming platform, you'll see you can use it to improve visualization with machine learning and generative AI to model these complex energy flows and predict future scenarios. At its heart, GridGuru allows the modeling of power flows through the energy network. This is from an individual feeder level all the way up to whole of system level. What makes GridGuru truly different is its ability to engage stakeholders directly. It's not just about data and models, it's about opening up the network to real conversations. Whether you're talking with a regulator, a developer, or the general public, GridGuru provides a way for everyone to visualize and explore the network in a way that makes absolute sense for them. Thanks to the large language model integration, stakeholders can interact with the platform using their own language, making it accessible to all parties involved to understand the impact, to identify the trade-offs, and buy into the solution. But let's dive into the demo.
Yeah, you're going to have to stop sharing so that we can share. Thank you.
Okay, let's take a journey to Donald. Donald is a regional town in Victoria, located about 140 kilometres from Bendigo. Like many other rural towns, energy travels a long way to get here, ultimately stepping down to reach Donald at 22 kVA or kV. Donald has a penetration of 30% solar and EV penetration of 5%. They're currently considering a microgrid to deal with some of the challenges they have that include power outages and power quality issues. Let's start with a typical fine spring day in Donald. Clear skies, moderate temperatures, and solar generation working as expected. It sounds like a straightforward day, but as you know, even on a calm day, the network is under constant pressure. Let's run the simulation and observe how the power flows through the network. Over to you, Phil.
Thanks, Jason. So what we can see here is the Unity editor, and I've used some of the tools from the ecosystem to import data from the OpenStreetMap so that we can represent the town of Donald. And I've also imported data from Open Infrastructure Map, which shows where the distribution transformers are. And in Donald, we have 24 distribution transformers. And you can see each of the low voltage networks wrapped around each of the transformers on this model here. We've also used load data from a CSIRO study. We've used some census data to facilitate how many people are in each house. And the data from OpenStreetMap allows us to actually map out the physical location of the network. So what we're going to do now is just draw your attention to the time up the top here. It's 6:30 in the morning on a fine spring day. And we're going to speed up the model to approximately 800 times normal speed. And you'll start to see the sun come up. And as the sun starts to come up, each of the solar panels in each networks are starting to generate power. And as they generate more power than they need for the household, they're providing feed in, so they switch to yellow. So what you can see here is we have a mix now of households generating power and households consuming power. So the ones in red are using grid power. And later on, you'll see some of these will turn green when we start to talk about community batteries. So right now you've got houses that are using grid power, houses that are using solar power. And as the day progresses, we'll get a little bit later in the day, you start to saturate the amount of solar power that is being generated in the networks, and you'll start to curtail. So the newer systems will start to curtail automatically, and the older systems will keep generating. This causes a few issues. So what we're going to have a look at now is use some of the large language model features that we have in here in GridGuru. And I'm actually going to go and ask the model to show me some networks that are having issues with curtailing. So I'll put in a prompt here, and these prompts are designed so that any of the different tribes that are involved with the energy system can ask whatever questions they like, so we can make these fit the way that people talk to their energy. So here we can see that we've got now 3 transformers that are having issues. So we can actually use GridGuru again to got to talk nicely to it. So transform, spell that correctly. And this is going to bring up a detailed graph of what's actually been happening in Transformer 0. And we'll be able to see what's been happening in the last 24 hours. So the black line is the total load, that includes all the air conditioners as well. And the yellow line is the amount of solar that's being generated. And you can see here on the right-hand side that as the day started to progress and we started to generate more solar, we actually turned it down a bit. And that's what you can see here, is that we had to curtail the amount of solar that was being generated. And so the system now is showing how the energy is flowing through the system, and this particular transformer is saturated and it's using curtailing. So I'm going to switch over to Jason again, and we're going to talk about how weather impacts these things.
Thanks, Phil. So imagine a weather front moves in, the clouds roll in, solar generation drops, and the temperatures suddenly spike by 10 degrees. Air conditioning units throughout the town start working overtime, increasing by 2.5 times. Suddenly, the network that was handling things rather smoothly is now under strain. Let's simulate what happens and see how the network changes under these new weather conditions.
All right, thanks, Jason. So as you can see, I've set the cloud cover to complete and put up the amount of air conditioner usage. You can use whatever data feeds you like to do these things. I'm just doing these manually to show some possible scenarios. So we'll speed this up again, get a bit of data happening. And what you're going to see here is as the clouds start to come in from the top right, the cloud cover will affect the amount of solar that's been generated. So all of these networks now are starting to not generate enough to saturate their networks. And you can see that this particular one is now below the load line, and we're now actually hitting the grid power to supply all this extra power that we needed for the air conditioners. So here you can see that these solar systems are now not curtailing, and they're generating as much as they can, but it's not sufficient to supply the load. And we're going to switch over to Jason again. And now we're going to talk about community batteries.
Great. Thanks, Phil. So we're going to revert our weather conditions back to what they were earlier in the day. So we're back to having a fine, clear spring day in the town of Donald. But we're going to introduce a 2 megawatt-hour community battery. The battery is designed to store that excess energy when solar generation is high and discharge it when demand spikes. Let's install the battery in the model and watch how it changes the operations within the network.
Thanks, Jason. So we're going to use GridGuru's conversational AI interface again. And here, this is a very specific prompt about installing a 2 megawatt-hour battery in a particular transformer zone. So we'll send that message off. And what you'll see is that this battery is going to be installed in transformer 0 area in a sec. There we go. And it's brought up the graph again. Now you can see we've got a 2 megawatt-hour battery in this area. And we're just going to speed up the model again. So now what's happening is the excess solar. So you can see here where the clouds came over. Now the clouds are just dissipating. The amount of solar being generated has jumped right up to the maximum amount. It's not being curtailed. And that's because all of that excess solar is now being put into the battery. That's what that magenta line that's coming onto the screen is. That's the amount of power that's going into the battery. So now we can see we've absorbed all the extra solar for a while. And then as the day starts to progress into evening, the networks without enough solar are going to start switching to red, as you can see here. But as it gets even darker in the afternoon, transformer 0 is going to switch to green, because this low voltage network is now using power out of its local community battery. And I believe the last one we're going to have a chat about now is EVs and the impact of those on networks.
Thanks, Phil. Donald currently has 40 EVs on the road, but what happens when the number grows? Let's simulate adding 10 more EVs to the mix, bringing the total to 50. Doesn't sound like a lot, but this does place significant additional load on the network, particularly on transformer 14, which is next to the train station where we've installed public charging facilities. Over to you, Phil.
Excellent. All right, let's have a look and ask GridGuru, have we got any distressed transformers? And we know that we do, because I put all of the public charging infrastructure onto transformer 14, as you can see. And so we'll just switch. We can actually use the menu system instead of just using the conversational AI. So we'll just go in here, and this is an asset search. This will find any asset in the system. Here we go, transformer 14. And we'll pop this thing up. Right, now what you can see here is this is quite a stressed transformer. We've got a lot of EV charging, that's the dark blue line. And because there are 6 chargers in that area, we can have a maximum of 66 kilowatts charging at any one time. You can see here when we switched the weather came in, to the cold front came through and dropped the amount of solar being discharged, being generated, and then went back up. Now we can see that that's quite distressed. So one of the things you can do with GridGuru is, well, let's test out some possible opportunities to fix things up. So I'm going to go and install a battery. And while that's happening, I'm also going to install a whole heap of new solar systems, because I really want to charge up all these EVs on the glorious free power from the sun. And we'll hit that there. That's going to take a little while, because that's going to go through and find 30 different meters in the transformer zone that don't have solar and install it. There we go. So you can see all the different houses that it was installed on. And now if we have a look at the graph, you can see here now that we've got a 2 megawatt battery installed and a lot more solar. Oops, sorry. Let's bring that graph up again. And so what that's doing is that is using now solar generated battery power to start charging up these EVs, which has, as you can see, drastically reduced the amount of load on the transformer. And that's it for me. Over to you, Jason, to wrap up.
Thanks, Bill. Today, we've demonstrated the power of GridGuru across a few scenarios: weather impacts, the integration of a community battery, and the challenges of EV charging. Each of these examples has shown how GridGuru provides insights to managing a modern energy network. GridGuru can help identify low voltage network constraints, increase hosting capacity to enable a more efficient energy transition, optimize grid configurations through strategic investments, and to utilize data insights to enhance customer engagement and network management. GridGuru can also model countless other scenarios: network upgrades, renewable integrations, demand response strategies. For example, let's consider Byron Bay in summer. The population swells as everyone comes from Brisbane down to Byron, usage peaks, EV penetration more than triples. We can now look at what happens to the network. We can talk about the potential solutions to deal with this event, and we can engage our stakeholders in how best to choose the option. Let's also consider a standalone power system at the end of a long rural feeder, say, for example, Broken Hill. What is the ultimate microgrid that we can install? What are the options? What happens? We can now engage our stakeholders again in what is the best solution to allow them to invest in owning the end outcome. When we look at this solution, we see it being used by multiple people or personas within an energy network: government and stakeholder relations, network planners, control room operators, DSO operators, even with connection applications. We've given you a taste of what's possible with this platform, and we look forward to answering any questions that you have. Thank you.
Thank you.
Sorry, thanks, Bill, and thanks, Jason. That was exceptional. I should tell you, in the time that has been given, we've covered a lot of ground. And I should also tell you that in the extended presentation, you can zoom down street level and have a look at impacts at street level and suburb level, and really engage those different stakeholders at all sorts of different levels. I think there'll be some questions that come from this, and they're starting to appear in Slido at the moment. But before we get to the questions and start talking in more detail, I'm going to introduce you to Marcus Wagner from Monash. Marcus was instrumental in helping this happen as well, and as is the way that race projects work, they're a collaboration between academia and industry. I'll introduce you to Marcus, but I'll also share my screen so that he can, so we can just see some of the content he's got to share.
Fantastic. Thanks very much, Neil. So it's a great pleasure to be working here together with Neil, with the RACE team, and with RedGrid on this particular project. I'll just ever so briefly outline what Monash has to bring here to the table. So Monash is the largest university in Australia with over 200 academics involved in energy-related fields across its 9 domestic and international campuses. My Faculty of Information Technology is known for being a leading entity in IT research and education in Australia, housing about 120 academics, including a dozen focused on energy topics. Our unique position of the faculty allows us to offer comprehensive, sustainable energy IT solutions, advancing the transition to net zero. Our work spans HVAC control, AI, infrastructure planning, user education, policy design, and decision support for everything from single EVs to battery fleets and national level infrastructure. As the academic lead of the project with RedGrid, I will collaborate with colleagues who are expert in visualization, time series analysis, software systems, cryptography, machine learning, optimization, and much more. In the audience there are, amongst others, Professor John Grundy, our software engineer extraordinaire, and Professor Heide Wu, leading expert in transportation modeling and stochastic optimization. Together with RedGrid, we look forward to exploring solutions to your challenges in the coming days and weeks, and to see GridGuru go to a much bigger project.
It's great. Thanks, Marcus. That's very good. So we'd like now to, if we could, explore some questions with the group. I might just put that Slido up again so that people can get that if they haven't already got it. Oh, there we are. So if you want to pose a question, by all means, have a look. First question for Phil or Jason, I think this is for you. Wayne asked, are the car charging modelling that you were doing on the model, were they fast chargers or standard chargers, and is there a way of changing that around?
Yeah, there was a mix actually. Some of the cars are charging at 11 kilowatts and some at 22. There aren't any of the 88 super fast charging ones, because I got the list of different types of car charging from an EV charging group. And so this was just the first attempt at a profile of how to, how would you mimic cars driving around a town, doing various bits and pieces, going to various locations, and then running out of power, and then deciding, well, do I use a public charger or do I wait till I get home? So it was all of these things can be manipulated. The really awesome thing that Jason alluded to before about Unity is that because it's all code driven and this idea of a game object, you can make these things, we can program them however you want. So at the moment I have 2 types of cars, but we could have as many different types of cars as we like.
Maybe if I give you a real life example. So a network operator has a charge card, EV charging infrastructure organization wanting to connect, and they're looking at multiple speeds of connection. Well, with the platform of GridGuru, you can actually model what happens. So let's put in a super fast charge versus slow charges. Let's put in 1 versus 4, and let's actually talk about what happens. This is the impact of the grid. This potentially is why your augmentation cost is as high as what it is. All of a sudden, you're able to talk with someone using a platform that can use real data that's reliable and repeatable, and they can actually see what's happening. And we believe that that's a way of completely changing the conversation, because we're now providing outputs that can be digested by that person. And if you look at that scenario, you can see that play out over many, many, many scenarios across the grid.
Thanks, that's really good. I appreciate that. We've got a question from Colin asking, can you run scenarios for, say, every day for a year based on actual weather data for an area that might be modelled, and then stack the results in some way?
Absolutely. Absolutely, you can. This particular version is designed, well, the idea of this one was that we do like an as-built. So you go into an area and say, right, this is the infrastructure that is currently here. These are the load profiles that we currently have. And then you can run a scenario from that. The work that we did with Monash allows us to actually do like load profiling over 24 hours, all sorts of interesting stuff. So basically whatever you can bring to make this model more accurate or more precise, we can incorporate that for you.
So I think the example of using a year's worth of data absolutely can be run. And then if I perhaps bring that back to a more tangible example, let's say I'm a control room operator. I'm now looking at what's going to happen based on the weather in the next 24 hours. I know I've got some planned maintenance happening. Are there any optimizations that I want to make to the grid in lieu of this weather that's about to come through, and avoid a truck roll? These are the scenarios that I can now run, see what happens real time. What are the potential scenarios that will occur, and what can I do proactively to optimize the grid in preparation of these incoming weather events that I believe are going to occur. That's an example of a use case that can be used with this platform.
That's excellent. I was talking to someone in one of the networks the other day who said that you know, of the 20 network studies that they would do for a block load or for a generator connecting to the network at different times, probably 18 of those studies never went anywhere. They were just, you know, resource allocated and expended for no reason. Is this a sort of tool where you could create open access for people asking those questions so that they could, for some of them, they could self-select and there'd be no need to do those more detailed network studies?
I think the answer to that is, so when we start to look at bringing in different types of load into the grid, we start to get into some very complex calculations. So I don't want to in any way not say they're really important, but I think what this can do is almost act like a bit of a screen to say, okay, well, we can look here and see if there are any obvious issues that would prevent or effectively screen out or screen in. This is a good potential site for them to do further work. And so what I believe that this would do is allow, again, you to be able to say, well, this isn't a good site, and here's the reason why. And not only here is the reason why, let me show you what is happening, versus another site which meets the screening test, but then needs to go through further additional engineer or power flow and engineering modeling that is required. So I think it's a good opportunity to use it as a screening tool, which would hopefully mean that some of those connections that have no chance at all never get investigated.
That's great. Thank you for that. Another question relates to the use of the large language model. So the interrogation mode that you used by asking questions. Obviously, for this trial, you spent a bit of time making sure that the prompts were going to deliver for what was needed for the presentation. But is it quite intuitive in developing those prompts for people who are not used to using large language models?
I think the short answer is, firstly, many of the population now use large language models. Actually, the data says over 80% of people at work use ChatGPT, and actually close to 75% are bringing their own models to work. So if you look at the latest Microsoft data, we are becoming more and more proficient in actually using large language models. In terms of using a large language model, most people now are using it, and the frequency becomes the challenge. But in terms of talking to a large language model, what's really great is you can talk to a large language model using the language of your tribe. If you are an electrical engineer, then you probably will talk to the model in a different way, perhaps if you're a network operator. And so there are ways of providing prompts such as persona prompts, etc., that can be used to really allow the LLM or large language model to talk to you in that way. So it really means it opens up accessibility to almost any type of user. And we see that as one of its true powers.
And one of the other true powers of OpenAI now is that you can provide your own set of tools. So rather than relying on the large language model to try and answer the question, what was happening there was it was getting the intent of the question and then using a bunch of tools that I programmed into it to actually interrogate the model rather than using public data to answer the question.
I think also, Neil, that was a very deliberate approach we took in architecture for this project to build it in such a way that's very modular. So new prompts and new capability can be quite easily added and navigated in the evolution of the tool. So we focused on a few use cases at this point in time, but the ability to add new, that's the true power of the platform, we believe.
Yeah, and one of the things that I really want to stress that I didn't have time to go into in the demo is that we started off with day zero, like the as-built of what Donald currently has. And then we played around with it. We put some batteries in and more solar and that sort of stuff during the model. So we came up with like our tuned version. What I want to be able to do is provide both sets of data to our generative AI and say, right, how do we get from day zero to our perfect net zero solution at day X, and get like a financial model and a project plan model and all these kinds of things and all the regulatory submissions that need to be done. So you can say, right, this is how we get from A to B using AI, and here's all the documentation that we need to actually facilitate that project.
Yes, also, you know, if you're a network and you're talking to government about proposed incentives for customers for different CER, it's very easy at different levels to model different levels of success of that incentive and the impact on the networks moving forward over time.
That's exactly right. And I think one of the things, if we think about Unity as a platform, it means you can run very sophisticated models, be them weather models, behavioral models, energy models, etc., and have that as a separate discrete, and then bring it into the model and actually model what happens. So imagine being at a community consultation where you're talking to the local town about a potential 2 megawatt-hour battery, and someone puts up their hands and says, well, why aren't we doing 10 megawatt-hours? Let's see what happens. Let's put it in. We can now have that conversation around how would it potentially impact reliability on the grid or have impacts around power flows. Of course, there's an economic cost associated with that additional investment in storage, but all of a sudden we're allowed to bring the community into the conversation to understand what the trade-offs are and ultimately buy into the solution. And we believe that'll speed up time in those approvals significantly.
Excellent, excellent. So just want to dive into the idea of this product. If it were to turn into a project, we're keen for it to do, it would become open source, meaning, you know, it's available to anyone who really wants to use it. But for next, does that mean there could be multiple iterations of this model inside? You know, the protection engineers could be using it, the operations center could be using it, consumer engagement could be using it, all in different ways, but having parts of it synchronized so that as the network changes, all the models are kept live. Is that how it works?
Yes, so one of the things that I've discovered over the last few years is a product called OpenStreetMap, which has been around for a very long time, and it's like a crowdsourced mapping solution, but it also stores infrastructure information as well, like power lines, wind farms, all that kind of stuff. And it's an extensible data model. So part of the open source plan that I've got is that contributors like community groups and networks and things like that will actually update OpenStreetMap to have like an open source static information about the network that other models can use, particularly the way that we've used that information to actually generate that entire town of Donald. That took about 10 minutes to actually generate using the tools. And that gives you this a really nice place to store all this information so that when, you know, a new battery gets commissioned or new information is available. Plus there's also people that just walk around putting stuff into OpenStreetMap, like, you know, they get a pair of binoculars and they look at the side of a transformer on a pole and actually put that information into OpenStreetMap to share this information so that many different stakeholders can get involved.
I think also just to extend on that too, Neil. So our ambition for the phase 2 project, Marcus and I have been speaking about working with some of their data architecture and security groups within Monash. We envisage an approach with this model where you can create grids or models for yourself and choose to share them, choose to keep them private, or choose to partially share them. So we will be working closely with that group to ensure an architecture that sort of agrees with everyone's needs, but also encourages that collaboration for sharing value and insights between projects. That's a real key characteristic of this solution and the ambition for the next project.
That's excellent. We might just move on now. Unless there's any other questions, if anyone wants to put any through. We're getting close to the top of the hour, and there's a couple of things we're just going to touch on with next steps. Is there last call for questions? Okay, well, we might then just pick up the last of the presentation. So just go to the next step. So right now, this is a really good prototype that we're really keen to build into a project that becomes open source and available to the wider network, transmission and distribution network, to anyone who is keen to be able to model inside this and do some work around this. So we're looking for partner build. We're not expecting people to put their hand up today, but we're hoping people will consider, is this something that could be valuable to us moving forward at a technical level, at a customer engagement level, at an investment level, at any of those levels. And if you think there's interest, then I'd encourage you to take down the details of both Neil, me, myself, and Annie, so that you can reach out and have a chat to us. And we're happy to either bring the GridGuru and Monash people together for a private meeting with yourselves and other decision makers in your organisation to talk about what it might mean to be part of this and how you could contribute to the development of the scope so that it is more useful to use moving forward. Once we get a sense of the number of parties that are interested, then we will more likely have a community workshop where we will talk about what we've learned so far, and we can start to talk about the costs associated with it. Obviously, the more people who are interested in getting involved, the more the cost will be spread across people. As a guide, you know, if this were to cost $3 million to land an open source version of this that's accessible for everyone, probably the industry partners are looking at putting in about half of that, just over half, about 1.6 million of that rate, and Monash getting involved with supplying the rest of that. I'm not suggesting it's going to cost $3 million to build. It depends what the final scope looks like. I just ran those numbers just so that we could get a sense of where that's at. So please reach out to us if you're interested. We're really keen to see if this has sparked some interest, and if you want to dive into some more use cases, if you want your regulatory people who are keen to understand what's happening with customer engagement moving forward, you know, if you want to talk to your protection and your planners, your protection engineers, your planners, and your network operators, whoever it might be, to get them to have a look at this and get a sense, then by all means, have a chat to us and see what we can do. We do have, this is just one example of a project that was trying to line up. There are a few other projects that are starting to happen around the place. There is discussions around what customer-centric cost-reflective pricing might look like. There is some discussions we're having right now with the network about what are the potential minimum and maximum demand impacts from cost-reflective pricing at different times of the day, and how do we build models that we could build into our regulatory determinations. We're looking at exploring the value stack that exists within what they might call distribution renewable energy zones, so industrial and commercial bulk and zone substations that might be looking to electrify. What are the benefits and the stack, and how does that look like if it gets coordination into the way that it electrifies, to the way that it approaches flexible load, to the way it looks at utilising all of the roof space in that industrial or commercial area, what the business models need to look like for the decision makers within the customers, what impact it could have in reducing multiple augmentation over multiple years, and optimising the size of the networks and managing demand across the network, sharing things like storage. So that's a really interesting project that's starting to take shape, and we've got some interest from industry putting money into that already. There's a project discussing household battery adoption and grid integration, and how we move adoption to the next stage, to that stage we saw solar move to, where uptake really picked up. It's a really interesting project around PV generation and the impacts of bushfire cloud patterns that it can have on network output for PV. We're talking to some of the water utilities about next generation water optimisation, flexible load. There's a suggestion of a project related to really deep dives into power quality in high CER environments. We're doing some really interesting modelling, or we're starting to explore really interesting modelling using the Plexos model in the distribution network, particularly of CER, and also just looking at things like what the impacts of the new SOCI framework is on response rates for CER protection and network equipment moving forward. It's just an example of some of the projects that people are talking to us about. If any of these strike some interest with you, feel free to reach out to us, or if you have your own ideas for something that you think you'd like to see, by all means, let us know. So that concludes the proceedings for today. We hope we don't hope, in a month's time, we will be running another webinar. That one will be on CR orchestration program that was run in Western Australia recently that involved the DNSP and the retailer and an organisation called Plico. Had some really encouraging results from consumers at the response level and at the level of trust that was experienced and at the price that was paid for the actions that were taken. So definitely something that's worth joining us for if you're interested in that space, or if there's someone in your organisation who might be interested in that space. So watch out for that invitation coming through shortly. But with that all done, I'd like to close proceedings for today. Thank all of the team from RedGrid and Monash for joining us and helping us, and for the people at RAISE who helped organise this. Annie, thanks for all your help. Ori, and Mylene, thank you for everything you've done to make this happen. Thanks for coming and joining us today. We hope to talk to you more about some of the exciting projects that are happening in the energy transition moving forward. I hope you have a good day. Thank you very much.
Thank you.